Okay, guys, in this video, we are going to integrate one more integral with respect to the arc length. So here we got x plus y plus z ds. Now, C is actually a line segment connecting 1 and then negative 1, 0, and then it connects it with 5, 8, and 1. Okay, so the first thing we need to review is how do we make a parameterization for a line segment. So this is something that everyone has to know. It's very, very important. Hopefully, maybe you've already done this and you already remember, but if you do not, let me remind you. So first, we're going to copy the starting point. So that's going to be 1, negative 1, 0. Okay, and then it's going to be plus something t plus something t. Each of the something has to be a number. Now, it is very important to understand that the something is not just going to be 581, because this something has to be the directed line segment that connects these 2 points. Think of it as P and this is Q. So what is vector PQ? So you subtract the starting coordinates from the ending, right? So this is going to be 5 minus 1, which is 4. This is going to be 8 subtract negative 1, which is actually going to be positive 9. And 1 subtract 0, that's going to be 1. So that's how you'd make a parameterization. Also, you need to know that t changes from 0 to 1. Okay, so that's important. Because why? Why does that work? Well, trying to make this a little bit prettier. It works if you were to substitute t equals 0, right? Well, then you would have gotten 1, negative 1, 0, right? Which is what's supposed to happen. And then if you substitute t equal 1, then you should check that you will get your point 581. So 1 plus 4 is 5, yes. Negative 1 plus 9 is 8, yes. And 0 plus 1 is 1. So this means that parameterization is correct, so I was able to check myself. Okay, so let's go ahead and enter the parameterization here. And like I said, for the line segment, the way we made the parameterization, again, it's not the only one. There are infinitely many different ones. But the way we made it, t goes from 0 to 1. Okay, so how do we simplify ds, which is like the piece or differential of the arc length? So we take the square root, and then we have x prime squared plus y prime squared plus z prime squared. And at the end, we're supposed to add dt. Okay, so what is the derivative of x? Now, that's very simple because x is just 1 plus 4t. So derivative of it is 4. Y is negative 1 plus 9t. Derivative of it is 9. And the derivative of 4t is obviously 1. So now we just have to compute what this is. So this is going to be 4 squared plus 9 squared plus 1, 98. So that should be square root of 98. So that square root of 98 is going to be somewhere in the answer. I am not going to simplify it. There is a way to simplify it, but I don't care about that. Okay, so what I do want to know is what am I going to integrate? So what I'm integrating is x plus y plus z. So let's go ahead and add that. So we substitute in x equals 1 plus 4t. We substitute in the parameterization. And then y equals negative 1 plus 9t. And z equals t. Okay, so of course we need to collect like terms. So we've got 4t, we've got 9t, and we got t. So that would be 10 plus 4, 14. So 14t, and then 1 minus 1 is actually going to be 0. So that just evaluates to 14t. Now, I didn't finish integrating, obviously. I just put it so I don't forget the root. But integrating 14t from 0 to 1 is very simple. So that would be like 14t squared over 2 or 7t squared from 0, 1. So that's just going to be 7. So it looks like I got 7 square root of 98 there.